3.2 Isosceles and equilateral triangles. In this section, we're going to dive into more properties about triangles, specifically with isosceles and equilateral triangles. Now, we did learn that an isosceles triangle has two congruent sides. Now, we refer to the congruent sides as the legs, and we refer to the base as the non-congruent side. Now be careful. Base does not necessarily mean the bottom of a figure. What am I talking about? Look in the margin. In this diagram here, in this isosceles triangle, remember the equal sides are the legs. The base is actually the top this time. It's the non-equal side, the non-congruent side. The base angles are those that are attached to the base. So they're opposite of the legs. So in this triangle here, these are the base angles. So those are the base angles. And this up here is the vertex angle. This is the vertex angle. It's the angle that connects the legs. So look, here's one of the legs. Here's the other leg. They meet up at point A. That is the vertex angle. Why is it important to figure out where the base is, where the base angles are, where the vertex angle is because it turns out that in an isosceles triangle, if two sides are congruent, then two angles are congruent. Very specifically, the base angles will be congruent. The angles that are opposite across from, meaning if I go through the center of the triangle, if I'm going from that side to one of the angles in the corner, and going across from that side to the other angle in the other corner, those angles must be equal. Angles across from equal sides must be equal. Or you can just think of it as if it's an isosceles triangle, here's my legs, here's the base, the angles attached to the base must be congruent. So that means angle B has to have the same measure as angle C. So if you know B is 50 degrees, C is automatically going to be 50 degrees as well. Now you can also work that backwards. This is the converse of the base angles theorem. Now converse just means you can use a property backwards by switching the if and then part. Like the base angles theorem was if the sides are congruent, then the angles are congruent. The converse of that would be if the angles are congruent, then the sides are congruent. So that means if you know the two angles are congruent, it must be isosceles. And which sides are congruent? Well, remember, the equal angles are attached to the base. That means the legs must be congruent. So AB must be congruent to AC. Another way you can do it is think, what side is across from angle B? AC. That must be equal to the side that's across from angle C, which is AB. Okay, now we want to be really, really careful now. Is X a part of an angle? Is it a part of a side? Because while yes, we did learn that the angles on the inside of a triangle add up to 180, we never want to involve 180 if X is a part of a side because we don't measure sides in degrees. We measure them in normal units for length, like inches, meters, centimeters, something like that. So we really want to be focused on what is X. In this one, X is an angle inside this triangle. Now I notice that this triangle has two equal sides, which means it is an isosceles triangle. These are the legs, meaning the non-congruent side is the base. And we know in an isosceles triangle, the base angles are congruent. So if that's X, I can also call that X. So that means the X plus the other angle has to add up to 180. So combine your like terms. I got 2X plus 50 equals 180. Subtract 50 from both sides. You get 2X equals 130. Divide both sides by 2. And you get X equals 65. Again, I use the fact that it had two equal sides to say, well, the base angles must be equal. So if the one's X, the other's X. And then those are angles on the inside of a triangle. Angles on the inside of a triangle add up to 180. Now be careful. You don't automatically want to call the missing angle X. While yes, I do notice that this is once again an isosceles triangle. These are the legs, meaning this missing side here is the non-congruent side is the base. And remember, the base angles are equal. The angles at the end of the base, that one and that one will be equal. So that means if that's 77, this one also has to be 77 degrees as well. Again, because it's isosceles, if the legs are equal, the base angles are equal. So once again, those are angles on the inside of a triangle, and all three angles on the inside of a triangle add up to 180. Combine your like terms on the left, the 77 and the 77 will give you 154. Subtract 154 from both sides, and you'll get x equals 26. Once again, x is a part of an angle here. How do I know that? It has a degree symbol. I've got two equal sides. I've got a box up here, which means that is 90 degrees. Okay. Well, if this is x, now these are the legs, this is the base angles are equal, so this is also going to be x. So that means x plus 90 will equal 180 because they're angles on the inside of a triangle. Combine your like terms, you'll get 2x plus 90 equals 180. Subtract 90, you get 2x equals 90. And you will get, when you divide by 2, x equals 45. What did you notice about your answer here? 45. Turns out, in every isosceles, right triangle. So that means it's got a right angle in it and it's got two equal sides. The acute angles are always 45 degrees. Always. That's always true. If it's both a right triangle and isosceles, the acute angles have to be 45. They have to be. They can't be anything else. Now, we're not actually going to do this problem, but what I'm talking about is if I gave you this problem right here, you might be thinking, oh, I don't have enough information to do this problem to solve for x. Actually, yeah, you could just say, well, it's right and isosceles, so that angle has to be 45. You could add the 5x and 5x plus 90. That's just way too much. Common mistake in a problem like this, students see, hey, it's a triangle, I must involve 180. Nope. Look at x. Is that a part of an angle? No, it's not. There's no degree symbol. That's a part of one of the sides. It says inches. We measure sides in inches, not degrees. So we don't want to involve 180 at all here. In fact, I have tick marks. That means those sides are congruent, which means all I need to do here to figure out what x is set the 3x minus 4 equal to 16. That's it. That's all I have to do. So I'm going to add 4 to both sides, and I'm going to get 3x equals 20. Divide both sides by 3. You're going to get a decimal. You're going to get x equals, and we'll just round to one spot, 6.7. Now you could leave your answer as 20 over 3. That would be acceptable as well, because that's actually the exact answer without rounding. Find the value of x, then find the perimeter of the triangle. Okay, this is a two-part problem, so I first need to solve for x. Then I need to find the perimeter. Now remember, to find the perimeter, we add up the lengths of all three sides. So I've got this red side here, I've got this blue side here, and I've got this green side down here. So if I add whatever the red is plus the blue plus the green, that'll give me the perimeter. I don't want to involve 180 because these are side lengths, they're not angles. But speaking of angles, I have, and I'm going to highlight them purple, 2 equal angles. Well, if I have 2 equal angles, that means I must have 2 equal sides. That means this side has to equal this side. So I can figure out what x is by taking the blue part and setting it equal to the red part. If a triangle has 2 equal angles, it has to have 2 equal sides. Very specifically, the sides that are across from them. Or you can think, hey, those are the base angles. The red and blue must be the legs. They must be equal. So I can subtract x from both sides, and I'd get 2x plus 2 equals 6. I can subtract 2 from both sides, and I'll get 2x equals 4. Divide both sides by 2, and I get x equals 2. Now, I did all that work just to figure out what x is. I can now figure out what the sides are by plugging in to here. So that side is 8. And I can also plug it in here, and that will also give me 8. So now to find the perimeter, all I need to do is add together all 3 sides of this triangle, and I will get the one side is 8, the red side is 8, the blue side is 8, and the green side is 12. All I need to do now is add those together, and I will get an answer. The perimeter is 28 inches. Now, we did mention before that equilateral triangles are also equiangular. So we know if all 3 sides are equal, all 3 angles are equal. If all 3 angles are equal, all 3 sides are equal. And we also know that when that's the case, each angle has to be 60 degrees. It cannot be anything else. So let's find the value of x. Well, let's take a look at this triangle. I know that all 3 sides are equal. If all 3 sides are equal, all 3 angles have to be equal as well. If all 3 angles are equal, that means every angle has to be 60 degrees. So all I need to do is set 3x equals 60. Now, you could have set it up like this. You could say, oh, they're all 3x, and the 3x plus 3x plus 3x equals 180, but that's a lot of work. You could just remember that, hey, if all 3 sides are equal, every angle has to be 60 degrees. So all I need to do is divide 60 by 3, and you get x equals 20. Now, if you wanted to do it the long way, that's fine as well. You can add the 3x plus 3x plus 3x and get 9x, and you'll wind up with the same answer in the end. It's really up to you which way you do it. You don't have to do it both ways. Whatever way makes more sense in your brain. If you want to use the shortcut here, use the shortcut. If not, the left equation is fine as well. Now, in the next diagram, the x is associated with a side. It's not an angle. How did I know that? There's no degree symbol here, and it says centimeters. Now, if I look at this triangle, every angle is 60, 60, 60. If all 3 angles are equal, then all 3 sides have to be equal as well. So the x plus 12 has to equal the 257. So now all I need to do is subtract 12 from both sides, and you get x equals 245. Same thing here. 3 equal angles. That means I have to have 3 equal sides. So x has to be 31. In this one, I have 3 equal sides, which means all 3 angles have to be equal, which means they all have to be 60. So if you use the shortcut, you could say, hey, 2x equals 60, and just divide by 2, and you're done. Or, now you don't have to do it this way, but if you don't want to use the shortcut, you could say, hey, if all 3 sides are equal, all 3 angles are equal, which means all 3 angles are going to be 2x. So then you could say, well, the angles on the inside of a triangle add up to 180. So it's a lot longer, but you'll get the same answer in the end. The 2x plus 2x plus 2x would give you 6x. And then you divide by 6, and you'd get x equals 30. So either way, you get x equals 30. At this point, I'd like you to pause the video and try out all the problems under example 4 on your own. And when you're finished, you can unpause and check your answers. Now, there is a shortcut for this one. I'm going to show both ways. I recognize that it's got 2 equal sides, which means it's isosceles, and it's a right triangle. And we did say that if it's isosceles and right, then the acute angles have to be 45. So the 9x has to equal 45. So x is going to equal 5. Let's say you didn't remember that. That's perfectly fine. Well, if that's 9x, this has to be 9x. And you could say 9x plus 9x plus 90 equals 180. You can combine your like terms. The 9x and 9x will give you 18x. You could subtract and then divide, and you'll still get x equals 5 in the end with a bit more work. So it might be in your benefit to remember these shortcuts whenever possible. In this triangle, I notice all three angles are equal. They all have an arc mark, which means all three sides have to be equal, which means x equals 4. Next problem. All three sides are equal. They're all 5, which means all three angles are equal. So you have two options. You have the shortcut, which means, hey, if all three sides are equal, all three angles are equal, which means they will always be 60, 60, and 60. So that 5x has to equal 60. That's the shortcut. And you can just divide by 5 and get x equals 12. Or, let's say you don't want to remember the shortcut. You could remember all three sides are equal, all three angles are equal, so they're all going to be 5x. And you could do 5x plus 5x plus 5x equals 180. Combine your like terms. You would get 15x equals 180. You would divide by 15, and you would still get x equals 12 in the end. Next diagram. This is isosceles again. How do I know? It's got two equal angles. If it's got two equal angles, then it has to have two equal sides. The equal sides will always be across from the equal angles, so the x plus 1 has to equal the 4 there. Subtract the 1, you get x equals 3. Next, I've got two equal sides. This is isosceles. That means these are the legs. And this over here is the base. Now, I'm not going to involve 180 here. Why? Because I don't know the vertex angle. Where I just put that little arrow there, I don't know that angle. So I don't want to involve 180. However, if the legs are equal, the base angles are equal as well, which means this angle has to equal this angle. So I'm going to set the 9x equal to 72. Again, just because it's a triangle, you don't always want to just go, oh, involve 180, involve 180. Not true. Again, I saw it has two equal sides, so it must have two equal angles. Very specifically, the base angles are going to be equal, so the 9x has to equal the 72. Divide both sides by 9, and you get x equals 8. In this triangle, I see it has two equal sides. Those are the legs. The non-equal side is the base. And remember, the base angles in an isosceles triangle are congruent. So if that's 81, this is going to be 81 as well. So my equation is going to be x plus 81 equals 180. Again, all three angles on the inside of a triangle add up to 180. Combine your like terms. 81 and 81 is 162. Then all I need to do now is subtract both sides by 162, and you'll get x equals 18. Find the perimeter of the triangle. To find the perimeter, I need to add up all three sides. Well, they only gave me one of the side lengths, but what do you notice about the angles? 60, 60, 60. Oh, it's equiangular. If all three angles are equal, then all three sides have to be equal as well. If the one side's 27, then all of them have to be 27 as well. You could add them, or you could just multiply by 3. It really doesn't matter. You'll get the same result in the end, and you'll get that the perimeter is 81 feet.